Hey everyone, we're going to be working on notes for definite integrals today. Remember, integrals is just another way to say antiderivative, that going backwards from a derivative. Okay, so here is the good news is you no longer have to write plus c, but you have to notice a few things before you get to skip the plus c. The biggest thing is right here, there are numbers in front of that squiggle line, that integral symbol. So anytime there's numbers there, then this is something we can actually evaluate and get a total answer to. So if there are those two numbers, then we can actually evaluate this. Okay, so I'm going to write that up here. Only if there are numbers on the integral symbol, can you do this? Can you skip the plus c? Okay, that's the only time that you can do that. All right. Let's take a look, upper limit, lower limit. Let's take a look at what this means. First, let's just do the calculation for it. Okay, so the first thing we're going to do is do the antiderivative. So that's going to be x to the third over 3. And then we're going to put a bracket at the end of it, and we're going to copy those same two numbers down, so 3 and 0. So now we're going to evaluate this expression both with 3 and a 0 and a minus sign in between. So number one step is we're going to plug in 3. So plug in 3. So if I do that, I'm plugging in this number 3. Okay, then I'm going to get 3 to the third over 3. Then we're going to do a minus sign, minus, and then plug in 0. Okay, it is always plug in the top number first, then the minus sign, then the bottom number every single time. So this is just going to turn out to be 27 over 3 minus 0, which would just be 9. All right, pretty cool. All right, what the heck did we just do? Okay, it's kind of cool. You get find out a little bit of something. Do you remember how when we said before that derivative was the same thing as, where do I even write that? How about here? Oh, it doesn't like me writing up there. Okay, derivative is the same thing as slope, right? Okay, here's the really cool thing. Whew, that looked fun. Okay, so if derivative is slope, here's the really awesome thing is that when we're doing integration, we're actually finding the area under the curve. Okay, area under the curve, that 0 to the 3, those were your x's. So here's your 0, here's your 3. We're going to be finding the area from 0 till 3, and then we're also going to be taking 3 all the way up to the graph, which happens to be x squared, and we're going to use these points and calculate this entire area in here. It kind of looks like a curvy triangle. So here's what we're doing, right? We've done area before, that's always just whatever the base is times the height. Okay, so the 0 to 2 is your base. In this case, the base is 3. Right? Our height changes though, and the height in this case is always whatever that y value is for x squared. So it's going to change over the time, so that integration is going to calculate all that area between 0 and 3. Pretty cool, right? So area, so the base is going to be from 0 to 3, so that's from lower to upper. And then the height is always going to be the vertical distance from the curve to the x-axis. So we stop right down here. You have just learned a new secret of calculus, people, that calculus, when we do integration, is really just finding area under a curve, and the shapes no longer have to be forms that you know from geometry. They don't have to be circles and you use the circle formula. We can just use calculus for all of it. Okay, so I know I'm super excited, right? I love this part of it. Okay, so on this one, we're just going to first practice just doing the math, doing the technique. So we're going to take the antiderivative, that's going to be a 2x, put a bracket, copy the top and the bottom number, the upper and the lower limit, plug in the 4 first, so we get 2 times 4, then a minus sign, then plug in the 1, 2 times 1. So this is going to be 8 minus 2, this is 6. All right, so this is the last one we're going to tie in visually so you can see what we're doing here. I'm going to mark off on my graph from 1 to 4 on the x-axis. So that's from here to here. right? Here is 1, here is 4. That's going to be my base. So I can already tell that my base is 3 wide, right? That goes left to right, 3 spaces. The line that I'm drawing under, this one right here, is the equation y equals 2 that we're getting from the equation after the integral symbol. So if we know that the area is base times height, and I already know the base is 3, height is the same the whole time. The height is always from the curvy curve to the x-axis. So in this case, we have a height of 2. And guess what? Bam. Okay, the area then is the base of 3 times the height of 2, which is 6. And we found it using calculus, and we found it using graphing areas. Sweet, right? Okay, from here on in, we're going to just focus on technique, but we're going to keep coming back to what is it that you're doing so that you understand that it's area under a curve, okay? All right, so now we're just going to zoom through a whole bunch of these and just go through the algebra of plugging them in. So on this one, if I integrate, it's going to be x to the 4th with a 2 in front. This one's going to be x to the 3rd with a 2 in front. This one is going to be x squared with nothing in front. And usually I'd write a plus c, but I see those numbers, so I put a bracket instead. Copy those numbers down, 1 and a negative 2. And then again, I'm just going to plug them in, top number first. Now notice this isn't just one term this time. So this time I might decide to use parentheses and go, okay, this is really 2 times 1 to the 4th plus 2 times 1 to the 3rd minus 1 squared. Okay, that's from all plugging in the 1. Then we have a minus sign. Then we have to do the same thing plugging in a negative 2. So a negative 2 to the 4th plus 2, a negative 2 to the 3rd minus negative 2 squared. And that's what I need to calculate. So just take your time, try not to make mistakes. So this one's just going to be 2 plus 2 minus 1. And then over here, a negative 2 to the 4th power is 16, so this is 32. A negative 2 to the 3rd power is negative 8, so this is minus 16. And a negative 2 squared is a 4, so that's a minus 4. So it looks like over here we've got 3, and over here we've got 16 minus 4 is a 12. And this time our answer happens to be a negative 9. That's okay. Even if we're talking about area, what all that means is that most of our area was below the x-axis, okay, that it went up to the x-axis instead of down to the x-axis. Okay, so we are allowed to have positive and negative answers, no big deal. On to the next one, number 3. All right, so here we go, raising it up by a power. Minus x squared, this is going to be a 3 over a 2, put my brackets in, a 2 and a negative 2, move it up to the top for you. Okay, just making sure that that would have really gotten me what I wanted. I would have put that there. Yep, everything looks good, so we're going to plug in the 2 first. So we're going to get 2 to the 4th over 4 minus 3, 2 squared over 2, that's my first part. Then a minus sign, then I'm going to go plug in a negative 2. So negative 2 to the 4th over 4 minus 3, negative 2 squared over 2. And then we're going to simplify. So 2 to the 4th power would just be 16. Wait a minute, negative 2 to the 4th power would also be 16. Why do I think those are going to give me the exact same answer? 2 to the 4th is 16, 2 squared is a 4, negative 2 squared is a 4. This is exactly the same thing. This is just going to be a 0. You can't catch me. I'm not doing all that math. Okay, but you could if you wanted to, and you'd still get the same answer. It should be 0. Okay, all right, on to number 4. This is our trig problem. Now, sometimes when we teach integration and definite integration, this is called definite because we definitely have a beginning and an ending, we've already reviewed some trig stuff. We haven't that much for you, so I'm just going to walk you through it just so that you see what it is. We are okay doing the antiderivative and just calling it sine. We're okay putting the brackets on it right here. We're even okay writing out the whole problem, right? We can call this is sine of pi minus sine of pi over 2. And usually right about here is where people start to hyperventilate because they've forgotten how to do this. Okay, so just a quick reminder, here is our unit circle. This is where 0 is, pi, and then this would be 2 pi again because the circumference of a circle is 2 pi, right? Okay, so that means this is halfway, pi over 2. This is 1.5, 3 pi over 2. And they're specifically asking us to pay attention to the answers here and here. Those are the two numbers they want. Okay, if I want sine, sine is always the y value of the coordinate point. So this point right here is called 1, 0. So the sine of this one, because it's always the y value, cosine is always the x value. So sine of this one would be, oh, they don't want this one. So, okay, it would be a 0 there. Here we would be at 0, 1, and the sine value would be a 1. Here we would be at -1, 0, and the sine value here would be the 0 again. Get the idea? So sine at pi is really just 0, and pi over 2 is really just 1. So this is 0 minus 1. The final answer is -1. Awesome. All right, down to number 5. This one's a little bit uglier. And taking a look at this one, square root, right? So we're going to do this one. So let's go. So this one I'm going to rewrite as from 4 to 25, x to the 1/2 power dx. And then I'm going to add a 1 to it. So if I add a 1 to it in a denominator of 2, that's 3/2. And remember, we just put a 3/2 underneath it, which is a 2/3 flipped upside down. Okay, so it ends up with a 2/3. And then we normally write plus c, but now we've got a 25 and a 4. So next step is we have to start plugging those in. Now, if I have a calculator and I'm allowed to use a calculator, I can just go ahead and call it 25 to the 3/2 power. But if I'm going to do this one by hand, probably going back to radicals would be easier. So I'm going to call this one 2/3, and this is going to be the square root of x to the 3rd, right? And it is evaluated from 4 to 25. Okay, so 2/3 times, ooh, you know what else? I could do the square root first and do the 3 on the outside. That's going to actually be easier for these, isn't it? So I'm going to do this instead. Take the whole square root first and then cube it. So this is going to be square root of 25 and then cubed, and then minus 2/3, and then the square root of 4 cubed. Okay. All right, so picking up from here, we've still got the 2/3 in front. And now the square root of 25 is a 5 to the 3rd power. And over here, we have square root of 4 is 2 to the 3rd power. Okay, so 5 to the 3rd power first is 125. So this is going to be 250 over 3 when I multiply it by 2. And this one, 2 to the 3rd is 8. 8 times 2 is 16. So this looks like it's going to be 234 over 3, which I actually know does divide evenly and gives us 78. Okay. Again, you could use your calculator to evaluate this and do each part and just write them down. Right? All right, our last one, number 6. All right, so for number 6, we're going to go and just do the mechanical part here. So this is going to be -x squared over 2. Brackets from 2 to -2. Okay, first step is we're going to plug in a 2. So the 2 goes in for the x. So that's going to be after the negative sign, 2 squared over 2, then a minus sign. Okay, and then I'm going to recopy what was there, which was a minus sign, then a -2 squared over 2. So it's going to look something like that. Okay, calculating the first grouping of parentheses, that's going to be 4 over 2 and negative, that's -2. And then in the other grouping, it looks like we're going to have positive 4 over 2, which is 2, but it's got a negative in front of it. So this one looks like it's going to be -2 plus 2, which is equal to 0. All right. One last time, derivative is finding slope. Integrals is finding area. Have a good one, you guys.